So, very similar example to example 1. We have two carts that are moving on a frictionless surface. When they collide, they remain locked together. And that's a key point here to determine the velocity after the collision. So like with the last question, it's better to answer B before we answer A. Is the collision elastic or inelastic? Well, they stay locked together, so the collision is inelastic. Knowing that, we know that only momentum is conserved, not kinetic energy. So we'll go with the momentum equation. Pick one of the carts to be number 1, another one to be number 2. I'm going to pick the one on the left to be number 1, so that M1 is 4 kilograms, V1 3 meters per second. M2 then, 6 kilograms. V2, now this is where the direction comes into play again. We do need to account for the fact that that larger cart is moving in a different direction. So it would be negative 3 meters per second. And since we're looking for the velocity after the collision, V prime is what we need to find. The equation, M1V1 plus M2V2 equals M1 plus M2 V prime. Substituting in, M1 is 4.0, V1 is 3.0, M2 is 6.0, V2 negative 3.0, and that equals 4.0 plus 6.0 V prime. Working this out, 4 times 3 is 12. 6 times negative 3 is negative 18. And that will equal 10 V prime. Left side works out to negative 6, which equals 10 V prime. Divide both sides by 10. And needing 2 sig figs, we'll get negative 0.60 meters per second. Now, as always with vectors, it's generally accepted to not leave negatives when we can, so we can actually assign a direction instead of a negative sign. We said that the large cart was the one that was moving in the negative direction, and it was moving to the left. So a better way of putting this velocity would be 0.60 meters per second to the left.